I'm going to start a new series where I build this custom rocket. This is an interesting custom rocket. You can see that it has 6 fins. There's 3 fins on the bottom, 3 trapezoidal fins in the middle point. It's a little bit longer, the body that is a little bit longer than a Baby Bertha, but there's a longer nose cone on it. A very interesting rocket design. I'm going to go through all the details that I did to build this. There's a lot of details that are very subtle. Of course, the most important part of a rocket like this is that you want to make sure that your engine mount and your recovery system are extremely well secured. So I'm going to go through some of those details as well. You can see there's a sparkly a glaze added to this, the nose cone sparkles, the body sparkles, and even the red fins. And when you get this out in the sunlight on the launch pad, it just looks spectacular. So I hope you enjoy this series. I thought it was really fun. This is a custom rocket. I haven't built one completely custom for a while, but the rocket is done, and I'm going to publish the series. And after this, then I'm going to publish the series on the recovery system. Because just as important as launching the rocket, well, you have to get it back. So stay tuned for the second part of this, which is going to be some on the streamer that I'm going to build for this. I'm showing my Baby Bertha because this Baby Bertha somewhat inspires the new rocket that I'm going to build. We do have a launch opportunity coming up for the end of March, so I'd like to start building a few things, a couple rockets, a couple streamers to prepare for that launch. So given the Baby Bertha, it's got its very classic design. It's been around for a long time. But what I have is the remnants of a body tube from when I repaired my High Flyer XL. This piece of body tube is 9 inches long, and I said, well, that's very similar to the length of the Baby Bertha, so I'll use this, make a similar looking type of rocket, but a little bit different. So given I have this 9-inch piece of body tube, I said, well, let me put a nose cone on it, and I ordered a pack of nose cones. It came with this really cool long nose cone, so I'm going to go ahead and use this. So it's starting to look like a stretched Baby Bertha, which I think is really kind of interesting. Now for fins, what I need to do is I took the original stock that the Baby Bertha fins came in, and just use this as a fin guide. And I made some cardboard cutouts. So here's one cardboard cutout of the fins. Normally the fins look like this. You've got this resting point down here. And it's a very classic Baby Bertha look. Big Bertha too as well. What I'm going to do is say, well, let's flip this around like this. Now we see this fin can actually be used over here. And all I'm going to do is just flip it upside down, and you see the wood grain is still going the correct direction. So it's really nice. Is this now going to become a swept back fin, a little bit like an alpha, but it's got a little bit more kink into it. So this is going to look kind of interesting. So that's going to be the new fin design for this particular rocket. And since I have lots of body tube space to play with, I figured, well, I really like the looks of a 6-fin rocket because it gives me a little bit more opportunity to do a little bit of interesting painting on it, a little bit better type of design looks. So what I'm going to do is add another small fin like this and offset it like right about here. And there's going to be 3 of these fins and then 3 of these in between. So I'm going to build this very similar to what I previously did. My previous rocket that I did the 6-fin design on was a 13mm rocket. This is an 18mm rocket, so I'm going to put an 18mm mount in there, which means I can fly up the D16s on it. So now I'm going to add this extra fin, and now I'm going to start building. Stay tuned for the videos. I am doing a few special tips and tricks in some of the videos, which I think everybody's going to appreciate. So stay tuned. I start building this. Should only take a few days. So this is the engine mount. It's the standard SD's engine mount kit. These are all the parts. However, I am going to do 2 improvements to this. And again, I like to engineer the solution so that this lasts and is very reliable. To make this better. And these are little tips that I do for all of my rockets, but I don't see it talked about very often, so I'm going to show you on this one. Given all these parts, we have the engine mount tube. On the inside of this, you'll feel a little bit of a ridge. So when this is cut in the factory, apparently some nice knife pushes in here and it turns it around. It bends this in a little bit. And that can sometimes cause a little bit of a binding. If anything, it'll cause a little bit of wear and cause the tube to break down. It's very simple to fix. Just take an engine, put it in there. A little bit of a challenge there. And okay, all we have to do is just take this and push down and roll it a bit. And now we're all set. Perfect fit. The next step, and I don't see this done very often, but it's a very important step, is to treat the end of the tube with some CA glue. This will stiffen the end of the tube and keep it from fraying. when I use these in the field and I'm putting engines in and out, I notice that the engine eventually kind of like starts peeling away at the paper. And that can make it very, very difficult for the engine mount to keep its shape, and then it just starts tearing apart. So what I want to do is treat it with some CA glue. It's really easy to do. Just make a ring of the glue around the inside, like this. And then what I do is I take this is just a stiff wire, kind of wipe it around a little bit, smooth it around. A very, very important step, though, is that you have to wipe it with a paper towel. Now, you have to be careful because you might glue the paper towel inside. So take this, roll it up tight, and then put it in, twist real quick like this. And then take it out. Because you don't want to have any drops or any piece of dirt or anything glued inside of this, because if you do, it's going to be almost impossible to get that out or to even sand it down. So that's all you have to do. And again, it makes this now very, very tough. So when you put engines in and take them out, that the end of the tube won't fray. The next two tips on the engine mount is that the directions themselves show the approximate placement of the rings. They show a picture. They don't give any specific dimensions. I assume they leave it up to the Rocketeer to decide what they want to do based on the rocket design. But there's two things I am going to change. The first thing is that they show the aft or the forward centering ring right about here. I like putting the forward centering ring just over the engine hook, just like this. And then this provides a lot better grip on this engine hook to keep it in place. That I think is very, very important. The other thing it does is it shows this particular retainer here right up against this particular aft centering ring. If you look at this, I'll just hold this in place with my finger. It makes it really, really hard to get the engine in and get it back out. I'm not really sure why it's done that way. So I'm going to move this backwards, like right about here. Give me just a little bit more play so I can open this up a little bit more freely. So again, this is what I'm going to do for the decision on how I'm going to build this. So I'm going to start gluing this whole thing together. I'm going to be with you after everything is dry. Another quick little tip is that once you have your lines marked on your engine mount tube, it's good to sand off some of the shininess that's on there. But if you sand this off just a little bit, the glue will stick a lot better, give you a much stronger engine mount. It's really easy, just a couple of turns in here. That's all you need. I'm not trying to bring this down. I'm just trying to remove some of the shininess along each of the lines. And there you go. That's all you need to do. So we got the regular tube here, but then on each of these lines I've sanded it just a little bit to help the glue bite in and make a stronger engine mount. I'm now going to show you one of my favorite tips for putting this engine ring in, thrust ring or whatever you want to call it. There's always a challenge that you might push glue forward and get it inside the engine mount tube. So what I like doing is I put the thrust ring in just partially like this. Now what I'm going to do is I'm going to run a bead of glue around the outside of this so I can guarantee there's no glue on the inside. I'm going to push it in using an engine, a used engine, of course. So let me go ahead and do that. Okay, so I have this all set. All I'm going to do is just push this in. And there we go. We're all set. So the engine thrust ring now is in there. And there's no glue on the inside of this because any glue was pushed backwards rather than being pushed forward. I'm now going to put some glue on this rod and then wipe it around the inside here to put a fillet against the thrust ring on the back side of this. And then I'll be all done. Okay, so my engine mount is almost done. As promised, I put some glue as a fillet on top of the thrust ring. And this was a nice way to put this in because the thrust ring is perfectly square. Sometimes when you push it in, it kind of tips back and forth. Because I used the engine to push this in like this, it was perfectly square. And got pushed up square against the engine hook. And I'll have that fillet in there on top. So everything's going to be really, really nice. I can guarantee there's no glue pushed forward. Because any glue on the outside was pushed backward when I pushed this ring in. So this is the engine mount. I'm going to let this dry now, but there's one additional thing, and that is on the forward centering ring right here. I didn't put any fillet, and I'm going to show you why in the next video clip, because this is where I'm going to attach the Kevlar cord. Now, I don't use wood glue when attaching Kevlar. and that's why I did not put any glue on that. I don't want to have the two glues on top of each other. Okay, so I'm going to go ahead, let this dry, and come back and show you how I do the Kevlar cord. I'd like to continue putting together the engine mount. What's interesting is that because there's no real instructions for a custom mount, you have to think about how you want this rocket to work. I'm going to be putting a Kevlar cord on this, and the Kevlar cord is going to come off the end, and there's going to be a swivel on it. So what I like doing is I put a little notch on this forward centering ring, and then the Kevlar cord is going to run along the ring and upward. Now, there's a lot of people that will talk about this differently, saying, well, no, you should put it right here, or put it on the inside. The nice thing about this is that it keeps the ejection charge away from the Kevlar cord. So the cord's running along this direction, along the side of the body, and the blast is over here. I have had situations where the Kevlar cord is on top of the ejection charge. Eventually it burns through the Kevlar cord. It is not indestructible. So first thing I'm going to do is just make a little notch in here for the Kevlar cord. Okay, so I put this very small notch in here. You see, it doesn't have to be very big. And again, the purpose is to have the Kevlar cord rest in this notch so that it doesn't bulge the body tube when I slide it in. So you can see it fits in there quite easily. This Kevlar cord, I believe, is like 1.5 millimeters, something like that. It's a 300-pound cord. So I'm going to go ahead and start working on the cord to put this whole thing together. What's interesting is that I'm going to do some fancy things with some knots that I don't see in other videos. I'm going to show you what I like to do that works really well. The first thing I would like to do with this Kevlar cord is to address the problem of fray. Whenever you cut it, it starts to fray very, very quickly. And there's plenty of videos that show how to handle this. I'm just going to show what I like doing. I also saw a variation of this on a video by, I believe it was Dave Thomas, the first time I saw this, the REAR channel for Rocket Engineering and Research. So all I do is put a little drop on the end, a very, very small drop of CA glue. Now, the trick is to take a paper towel and just simply take this and squeeze it. Once you do this, it squeezes the glue inside. What's also interesting is that it instantly hardens it. See, it's instantly hardened. It polymerized the glue. So it's really nice. It's instantly dried. So now I can start working with it right away. There's something about a paper towel, maybe a napkin will work as well, that the glue instantly hardens. Now usually they show you cutting this off. You really don't need to, because now you just glued it right back together. The next thing I'm going to do is to make a slip line knot. Now this knot I've talked about before. It's very, very nice to use on the engine mount, because once you pull it tight, it does not slide. Kevlar tends to slide a lot, so this knot is really good in working with that particular problem. I've seen people use sometimes what's called a fisherman's loop and other things, and the big problem with this is that it doesn't seat very well against the tube. So let's kind of engineer a better solution. So I'm going to take this end and just go ahead and put a simple knot on this, on the end of this. So now you can see what this is. This is a very simple knot called the slip line knot. All it is just a knot tied on top of the cord itself. So I'm going to go ahead and tighten this. I can tighten this as tight as I want, not to exceed 300 pounds, which is highly unlikely. And pull this incredibly tight, get it very, very tight. So it's nice that this knot now is gripping this particular cord extremely well. So what's interesting about this knot, and I'll show you this right now, is that the little pigtail from this lies against the cord itself. So if you think about it, when this knot is pulled tight against something, what's going to happen is that this cord is going to have the little pigtail. You can just glue it down and everything stays nice and tight. So let's go ahead and do that. I'm just going to go ahead and put this over the engine mount and just pull it tight. And we want this to be lined up with our notch. And as you can see, what's really nice about this is that this knot is now pulled tight and the little pigtail is lying nice and flat. It's a really nice knot to use, and I use it all the time whenever I want to make sure that the knot pigtail is controlled. Now what I'm going to do is I'm going to make a very, very tiny drop of CA glue right near the edge, and that'll hold everything in place so I can do the next step of the gluing. So let me go ahead and put a tiny drop on there and let it dry. Okay, now to put the fillet around this Kevlar cord, I'm going to use this glue called E6000. Actually, if we take a look at that, you can see this cord now. I pulled the knot tight, the knot stayed put, a tiny drop of CA, everything is being held in place. So now it's going to be held in place very, very easily as I apply the rest of the glue. So I'm going to make a glue fillet and also have some glue across this knot with the E6000. Again, this is a polymer glue. It's got a chemistry similar to an epoxy. It has strength of an epoxy. When I say similar to an epoxy, this does not come with a separate resin hardener, but rather when the solvent evaporates, the glue will actually begin the polymerization process and begin binding. What's really nice, this has the consistency of a gel toothpaste, and that makes it really, really easy to put it in places, and it's going to stay exactly where you put it. So I'm going to show you what this glue is like. Take this out, and I'm going to just simply put some of this, let me get some of this junk off the end here. Okay. I'm going to just simply take a good glob of glue like this, put it onto this rod. See, here's a nice big glob of the glue, and I'm just going to go ahead and put it around the Kevlar cord. So let me do that. And again, what's nice, you can see it doesn't run, doesn't drip, and it just stays where you put it. Very, very nice for situations like this where I need to put a lot on. And if this is epoxy, it would just start running all over. Wood glue can be used, but there's a little bit of a difference. This glue, when it's dry, has a slight rubbery consistency to it, so there's a little bit of elasticity such that a severe shock, which happens on ejection, will tend to flex just a tiny bit. Wood glue is going to be much more stiff. So this gives us a little bit of resilience against the ejection. So let me go ahead and put that onto the actual engine mount. Okay, as promised, I applied a generous amount of glue, the E6000 glue, around the Kevlar cord and the front centering ring. What's really nice about this is it doesn't matter how it looks because this is going to be inside the rocket. Matter of fact, it's going to start contracting a little bit, so it's going to be smooth as it dries. But as you can see, I completely covered the Kevlar cord all the way. And when I got to the edge, the knot and the little pigtail are also covered. So this will be able to slide in now to the rocket very, very easily, just like this. So I'm going to let this dry for about an hour. It'll be pretty firm at that point. Now, the one drawback, or shall I say feature, or whichever way you look at it for this particular glue, is that even though it dries to be quite firm in about an hour, the instructions do say that it takes 24 hours for the chemical processes to complete and to get the strength of an epoxy. So you don't want to pull on it or work with this until this is quite dry for at least an hour. It's what I'm going to do. About an hour from now, I'm going to finish working on this. But you can't really put any stress on it for at least 24 hours, and I think they actually recommend up to 48 hours. So this is now the completed engine mount. You can see there were a lot of different tricks I used. I used a certain trick to put this ring in so it didn't push glue forward. I used the little trick here of the slip line knot, used the E6000 glue, and I backed up this little securing band a little bit more to give me some more flexibility in the actual engine mount. So I'm going to go ahead, let this dry, and then I'm going to start working on the rest of the recovery cord. So I'm almost done with the engine mount. We can see that the glue is now dry. It's smoothed out, pulled tight, soaked the Kevlar cord. And again, this has the strength of an epoxy. If you could imagine all this glue having strength of the epoxy, this is a very, very strong engine mount now because this ring has a Kevlar cord. It's got all that glue around it, and the cord now comes up to the edge. And it's really very, very strong. So I'm going to go ahead and put the swivel onto this. So continuing with the custom build, having the situation that we don't have any specific dimensions to do all this, the way I cut this to the correct length is I just line up the body tube with the engine mount. And sometimes the engine mount is out farther, sometimes it's flush. This is going to be a flush mount. And then just run the cord forward, and from the top of the tube, measure out about 6 inches. So right about here is where I'm going to cut the cord. So let me go ahead and do that. And of course, let's go ahead and put a little drop of glue on the end here. Make sure that the fibers all stay stuck together. I love this little trick. Think about it, here I go. I can touch it, nothing, no problems. So now I'm going to put the swivel on the end. It's real easy. I have some 3/16 heat shrink. I'm going to put the Kevlar cord through this. And I'm going to put this through the swivel. Now, what kind of knot do we want to tie? Well, I'm going to tie that wonderful slip line knot. I go ahead and tie it like this. Again, slip line knot is a knot where you simply tie it back on the cord itself. I'm going to make this about maybe 1/2 inch long, like that, maybe just under 1/2 inch. Tighten that up quite a bit. Now, this is the part I really like. Just go ahead and pull it, and now it's tight. Really, really nice. Now take the heat shrink, cover the little pigtail on the end, and also what's important is to cover the swivel too. So this now locks everything together. So all I have to do is heat this up with a lighter, and it's going to be very, very tightly gripped, and that's my end solution for this. I think my lighter has seen better days. Okay, so there we go. You see what's happened is that the heat shrink now has grabbed the swivel. So let me get this back over here. The heat shrink now has grabbed the swivel, and it's grabbed the Kevlar line and the knot. Everything is held together exceptionally tight. And the reason I like using heat shrink on this is if you just try to use glue, like CA glue, it's not going to bond onto the metal. And at least the heat shrink grips onto and shrinks around it. So this now gives me a very, very nice tight connection onto the actual swivel. Next step now is to put this inside the body tube. Now that the engine mount is done, I need to prepare the body tube, and I need to do two things. Same as before, there's that little lip on the edge, which forms when the factory cuts this off, so there's a little bit of a crimp on the end. Just put the nose cone in, just simply roll it like this. Now it's nice, smooth fit. Same thing on the other side, put this in, roll it, and then very nice, smooth fit. Works perfectly. The next step is what we did before, and that is to use CA glue to treat the end of this. And what's important is that after treating this, I have never, ever, ever had a body tube do what's called zippering. Namely, even though there's a Kevlar cord that shoots out of this, sometimes the cord can tear through the actual body. That's called zippering. I've never had that happen. Ever since I've coated this body tube with the CA glue, that's never happened. So you can see the way that I do this. I just put some glue in there, wipe it around with this long wire rod, and now that the glue is in here, same as before, I have to take a paper towel and smooth that out, because otherwise it's going to be a little bit gloppy, and that's going to be really, really hard to sand out. So just go ahead and finish it up like this. And there we go. I know we have the CA coated glue on the end. Let me just show you that in detail here. You can see it looks like it's kind of like it's got this wet look, but that's the glue that's now bound into the tube. So I'm going to go ahead and do the other end and finish this up. After I get this done, I'm going to put this on my drying rack for about maybe a half hour, just to make sure that all the glue is completely dry. So let me go ahead and do that, put the glue on this end as well, and then dry this for about a half hour. Since we are using a custom design and we don't have any specific measurements, we need to figure out where the glue goes inside the body tube. And you can do it like this, where you can take a simple hobby stick and put it to the aft end of the forward centering ring like this, and then mark a line where you want the body tube to be. In this case, it's going to be flush with our end of the engine mount tube. In some situations, the engine mount tube might be out farther or might be back this direction. So you want to have this mark where you expect the body tube to be, and this mark right behind this ring. So when you put glue in at this depth, when you insert the engine mount, it's going to go through that glue before it comes to a rest. Now I'm going to do the typical trick that people talk about, which is to take the cord and pull it through. This way, when I slide this inside, it will not glue the cord inside. And just a very simple solution to put a piece of tape on here to hold it in place so that it doesn't pull back out. Just like that. Okay, so now we're ready to start gluing this engine mount inside. And I'm going to use the E6000 glue again. What's really nice about this is that it's just the perfect solution for this particular problem. I've tried different types of glues, but what's really nice about this is that, again, it has the consistency of a gel toothpaste. So all I have to do is this, put a very big glob on here. Now I can smear this inside using this as a depth gauge. All I have to do is just go like this, put this inside. What I'd like to do is I'd like to just first turn it and leave the glob of glue in there and put another glob of glue inside. And I'm going to use a lot of glue on this, like right about here. I accidentally got a little bit here, but that's not going to matter. And go ahead and put even more glue in there. And what's nice is that I can just look inside of this. Now, why am I putting so much glue in here? The reason is that this glue will stay exactly in place for several minutes. And then when I finally put the engine mount through here, it's going to push all of this forward, and it's going to automatically create a fillet. So by putting all of this glue in here, we can get a very, very strong engine mount. And again, it still looks like a lot of glue. How many globs is that, like 5 or 6? So it's hard to probably see. I don't know if you can see this here, but inside the body tube, you see there's a great big thick ring of glue in there. And that's down just before the engine, or the forward centering ring is for the engine mount. So to push the engine mount in, it's going to hit that. Now what's interesting is I don't have to worry about this like I do wood glue. This is going to stay there for a few minutes. If I just use a little bit more, it'll stay there for several minutes. And it's not going to bind up on me, or it's not going to try to pull or anything. So I'm going to go ahead and finish this up there. Now to put the engine mount in, first thing to do is to put in the forward ring. Now that that's in place, we need to put some glue inside the body tube again so we can push this through. So the glue is up here, the forward ring is right about here, and here's the aft ring. So the whole idea is you just simply put the glue on the outside edge like this. Oops, the engine's falling out. There we go. Let's get that in there. Most of the glue is running back down inside. That's okay. It's going to run back. And get this engine mount out of the way. So now you can see I have a whole lot of glue in here too. What's nice is now I can insert this engine mount. It goes in very, very easily. Oops, this is getting a little stuck. There we go. The reason is that the CA glue made it just a little bit rough. So as you can see now, I made that flush. And this glue is a little bit more liquidy, so I like to leave the body tube up like this for at least a good 10 minutes, so that's going to run down and all of it's going to settle. Now this is going to be probably very hard to see, and I don't know if we can see this, but I'm going to shine a light down there. We can see that putting all that glue inside the rocket body created a very, very large fillet on the front of the centering ring. That visible? I'm not clear if that's visible. I think it's barely visible. So you can see all that glue down there. And now the engine mount is complete. All I have to do is let this dry, and we'll be all set to start putting the fins on. So let me do that. So another interesting tip is that right after I have put the engine mount in, we now know that there's a very large, thick fillet of the E6000 around the front centering ring. So what I do is I take the cord and push it back through, and now I pull it very tight and hold it against the body with a piece of tape. This does a couple of things. One is it keeps the engine mount in place so it doesn't slide around, but also this pulls it tight and into the fillet. So now the cord is now anchored into the fillet in the front of the forward centering ring. So again, that tends to give it a little bit more grip to relieve the stress. A very nice thing to do. And when you look inside of that, it's probably not that easy to see that. You see the cord runs all the way along the side, right square with the centering ring, and it's anchored into the glue. Really, really nice. I'm now going to make the custom fin guide. I did this for my other custom rocket that I just built for the 13mm one. What I'm going to do is take a piece of this streamer material. It's a different streamer material than I typically use, and overlap it, but just leave a little bit of a gap there. And I'm going to put a mark on this so I can get an exact measurement around the circumference. So now I have a measuring guide where I've got the circumference exactly marked on these two particular points. So I'm going to do the same thing I did last time. I'm going to take this particular length, divide it into 6 equal areas, and then mark it off. I'll mark off the launch lug and I'll transfer that to the body tube. Okay, so here's the fin guide. And again, there's going to be 6 fins. What's nice is there's plenty of space on this one. This is 133 millimeters across. Roughly every 22 and about 2/10 of a millimeter is where a line goes. This is going to be a fin. The only thing I need to do is to put a launch lug on there. I can put that in between any of these. There's no real problem with that. It's going to be real easy. Since the engine clip is on the inside, I don't have that on the outside, so I don't have to deal with that like I did on the other rocket. So I'm going to go ahead and put this on the rocket. Go ahead and mark this down, and I can put a launch lug in between any of these 2 lines that I want. And I'm just going to mark this nice big thick line and put a cross on it. So this will be my launch lug, and I can now go ahead and transfer this to the rocket. Let me do that. Okay, so what I've done is I put my fin guide on the rocket. Notice that this little cross, which was the location for the launch lug, again, it could be between any of the 2 fins. It doesn't really matter, but I just drew it in here arbitrarily. What's important when this guide is put onto the rocket that the plus is lined up with the actual engine clip, because you want the launch lug and the engine clip lined up. Okay, so that's it. That's all that we have to do. I'm going to go ahead, put little marks on here, and go find a straight door frame. So as I was playing with the fins, of course, this is the original Big Bertha look. Looks something like this. So by the way, I transfer all the lines to the body tube, and all I have to do is just sand them very lightly, and I'll be able to put the fins on. But I was looking at this, I said, well, the fin normally looks like this. So that's the Big Bertha fin. For what I'm doing, if I flip the fin like this, we can see that it still has the grain going in the right direction. I'm going to do something a little different. I'm going to have this fin offset by about 3/8 of an inch. Just have this staggered downward a little bit. So all I'm going to do is just draw a ring around the top so that all these fins are mounted the same. So this will look a little bit different. Normally it's going to look like this, but again, like that. It's a little bit different. Let me go ahead and do that. So I played with a few measurements. It turns out that this being 3 inches works out just fine. This is just a piece of heavy cardboard I used before as a drawing guide. I just put that on here, drew a ring at 3 inches. And so if you think about it, the fins, again, the Big Bertha fin would normally look like this. However, you flip it and go like this. It's going to now have a slight offset by about 3/8 of an inch. Rather than being up like this, it's just be back just a little bit. Again, give it just a little bit of a different style. What's really fun is when you're the architect and you're building whatever you want, you can make changes depending on what time of night it is. Now that the engine mount is in place, everything is all nice and dry, and I've got my cord right here, I can go ahead and start working on the fins. You see the body has got plenty of lines on it. This line is where the top point of the fin is going to be, and then this line goes all the way down. Now I like having the lines going all the way down. It's easier to help me sight down the body to see if the fins are straight. This is the Big Bertha stock, and I've built several Big Berthas. What's nice, I like to keep these because now I can very easily create a cardboard fin like this to help me start thinking about other fins. So these are always nice to keep. I keep them for every rocket that I have. And this is a 4x12 inch piece of balsa wood, and it just so happens I squeezed 3 fins onto this one piece. So I can squeeze one fin right here, squeeze another fin right here, and the last fin right up over here. So I can squeeze all 3 fins and make very effective use of this one piece of balsa. I have some very dark lines. That's where I'm going to slice the fins apart, and then I'm going to trim them down to each of the fins. So let me go ahead and get going on the fins. There is just one special technique I want to show on attaching the fins and how you can do it much more quickly, much more easily. But other than that, it's just standard stuff. I'm going to sand this down. I'm going to put some sealer on it, those kind of things. So let me go ahead and get going on the fins and get this ready. So just 2 quickies here. I separated the fins and I sanded them all down. Everything is all nice and dusty. For a sanding block, I like using an eraser. It has a little bit of give to it when I'm sanding, a little bit easier to work with. And I'm going to use some water-based sealer. I got this from the hobby shop. Been using this for 2 years. It works really nice. It's water-based. The nice thing about this is I put a couple drips on the fin and then just kind of smooth it out with my finger. It goes real quick and it dries in about an hour or two. So it's really nice stuff. So here's one tip on sanding the fins. Actually, for rounding them, I like using a glass nail file. The reason is that the glass has a very, very uniform grit on it, and it's really easy to use because all you have to do is just go like this, and you're done in just a minute or two. And it's as simple as that. Very smooth rounding. This is nice and stiff, unlike sandpaper, which flexes when you try to make it stiff with a block. This is a very nice, stiff type of thing to use, and it makes it really easy to control. And you can very easily sand your fins, and you'll be done. Have a professional looking job. Now for sealing the fin, again, I always like doing things as simple and convenient as I can. Stick a pin into the root of the fin. We got the sealer. All I do is just put a couple drops on here and just smear it around with my finger. This works quite well, quite effectively. And actually my finger is very good at detecting whether or not I have any runs or anything is uneven. And it's really quick and easy to use. When I get done, this nice knobby top of the pin, I just take it and I just kind of like tape it onto the side of the table and just let it hang over the edge. So again, very simple, and it works quite effectively, and your fins are done in no time. Okay, since this is a custom rocket and there's no actual dimensions for anything, I need to transfer the measurement from the body tube onto the fin. Namely, I've decided that I want to have the fin be down slightly. So this line around the center here, or it's actually off center, but all the way around, I mean, is where the tips of the fins are going to be. This is exactly 3 inches. So now what I need to do is on the root edge, I need to mark 3 inches on here because that's the point where the glue is going to stop. So I want to make sure I don't start putting glue on the part that's actually going to be exposed. So let me go ahead and do that. Okay, so that's pretty easy. Just put the fins together, marked off the distance. And again, the idea is that the glue needs to come down to here but stop. I don't want to put glue on this part. This will help me gluing the fins on. After this, I'm going to show you a little trick I use for putting the fins on. They go on real quick, and it is good for the fins that are a little bit larger. The first step, and this is often discussed in videos, is that you want to rough up the area where the fin is going to be glued on. And all I do is put a little circle next to where the fin is going to be. So I'm just going to rough this up a little bit. That's it. And the next one is right here. We're not trying to take this down, we're just trying to make the glue stick a little bit better, like removing some of the glossiness of it. Okay, so this next step is how I'm going to put the fins on. There's many techniques, so pick the one that you like the best. The technique I often see, this was a big Bertha fin, is you put some glue on here, you stick it on, you pull it off, let it wait for about a minute so for the glue to become really tacky, and then stick it back on. This generally works. The reason I say generally because I found that with heavier fins, the glue generally doesn't become tacky enough. And sometimes the fin will just simply fall off or pop off because it doesn't dry fast enough, even though it was stuck on. So what I'm going to do is I'm going to use a technique that I've just adapted for doing this. I'm going to run a bead of glue along this. However, I'm going to put a drop of CA glue in the middle of the fin. So what happens when you position the fin, the CA glue grabs it. So you just hold it for about 10 seconds while the glue sets. Then you can go ahead and start working on the other fins. So I'm going to take this, put a little tiny drop of CA glue right here, and then regular wood glue. And with this, you want to use very small amount, like this. Again, this is where this mark comes in, so I know exactly where the end of the fin is going to be. Okay, there. So now I have the glue on here. What's nice, when I stick this down, what's going to happen is that it's going to, CA glue is going to grab quite quickly, and then I can move to the other fin. So here's one of the fins with a circle on it, and I need to put the tip of the fin up here, and the bottom's going to be down here. So let me go ahead and do that, and I have this alignment line on here. And put it on just like this. I like to hold it for just about maybe 5 seconds at least. You see, it's already sticking. So this just turns a little bit. Okay, I'm just going to wait about 30 seconds and then I'm going to move on to the next fin. So I'm going to do this with all the fins. I'm going to smooth this out a little bit too. There's a little bit of globby glue on this. But you can see how quickly this works. The fin holds, it doesn't pop off, it doesn't move. That CA glue, that tiny drop just grabs that fin, holds it on, and now you can go ahead and let the rest of the glue under there harden and dry. And after this, you can put your fillets on. So let me go ahead and do the other fins real quickly. It's going to take about maybe 3 minutes. So here's the fins. And it took me maybe actually 2 minutes to put these on. Again, a tiny drop of CA glue holds the fin in place while the wood glue begins to grab. But this way it doesn't move. It doesn't move while that wood glue is biting in. And this will be dry in about probably another 5 minutes or so. So what I'm going to do is the next step, I'm going to put the fillets on the fins. I'm going to put the fillets on the fins, but I'm going to use a Tight Bond Type 3. The Tight Bond Type 3 sets a little bit more slowly, but it's a lot stronger. So I'm going to go ahead and use that. Then after I get the glue on here, the fillet glue, I'm going to put this on my heat rack. Now my heat rack is nothing more than a little floor heater, but it's pointing upward, and it provides a nice continuous warmth to keep the glue drying evenly. And the fillets will dry in maybe about a half hour. So I can put a second coat on of the fillets, and I get that drying as well. And overnight, everything's going to be nice and solid. So while the first fin fillet is drying, I'm going to go ahead and make these little small trapezoidal shaped fins. I have all the sizes marked out, and all I have to do is just transfer this to a piece of balsa wood. It turns out this particular piece of balsa wood was once a Big Bertha, and it turns out I can put these fins on here and just cut them all out. So let me go ahead and do that. And I know I'm running the wood grain vertically rather than with the leading edge. But with a trapezoid, it's kind of like evenly balanced, so it doesn't make a lot of difference. I know people will always argue about that, but from an engineering perspective, as long as the grain that exits the fin is somehow tied down to the actual root, you will be okay. So let me go ahead and cut these out and get them ready for gluing. So the second fillets of the Tight Bond 3, that's this one here. I use this for the fillets on the fins. It's almost dry. Dry enough that I'm going to mount the trapezoidal fins. And all I did was make a circle around here. So this fin, when it lies on the body, has half of it forward and half of it after the leading edge. Something like this. Again, just a looks thing, where I want to put it. I'm sure you could run this through a rock sim or something to say, oh, it's going to fly better like this or like that. It's going to fly just fine because these nice swept back fins are going to make it very, very stable. So again, I'm going to put the fin right here. Going to do the usual. I'm going to scuff this up a bit with some sandpaper. I already sealed and sanded the fins. So I'm going to go ahead and mount them the same way. A tiny drop of CA glue with some wood glue, then stick it down. So let me go ahead and put those fins on, and it'll take me about 5 minutes. Okay, so here's the rocket. I just glued these little fins on, the trapezoid fins on. I've not put the fillets on, but you see what it looks like. It's a pretty cool looking rocket, very unusual looking. I certainly like the 6-fin design. It adds a little bit more dimension to it. And I'm going to go ahead and put the fillets on here. 2 fillets of the Tight Bond Type 3. That's this glue right here. I'm going to put 2 of those on. I'll let this dry. By the time I get that on, it's going to be later evening, so I'll let this dry overnight. Then tomorrow, I can start the challenge of trying to figure out how to paint it. The one thing about lining these up, you can see I did put another circle around this point here so I can line up the tops of the fins, just to make sure everything was equally spaced properly. One of these fins, this one here, has a little bit of chip out of it. I can put a little bit of putty on that. I can fix that. Otherwise, everything turned out really nice. So let me go ahead and finish up the fillets, and I'm going to have a new rocket very soon. So the trapezoidal fins are almost dry. Looks like they're bonded on here really nice. Last thing to do is to add the launch lug. And the launch lug is right here. Here's the line for it. I'm going to put on here 2 3/16" lugs. Put one down here, one up here, each about maybe 3/4 of an inch long. I'll do the usual good stuff. I'm going to bevel it, and then I'm going to attach it with some E6000 glue. Again, the E6000 has the consistency of a gelatin toothpaste, so I just put it on here and then smooth it on. It's really nice for attaching launch lugs. And then it holds with the strength of an epoxy, which is what you're going to need for a launch lug. So with this particular rocket, I plan on using up to D16s in it. So I need to have a very strong launch lug, and I'm also going to make that 3/16. Okay, so let me go ahead and add that, and I'm almost done. So to start with, I put a sight line along the launch lug. Any square corner will do that. That gives me a better way to make sure that it's straight, so I can see exactly down the length of this. You can see there's a line on there, line is on there. And as you can see, the next step is to bevel the launch lugs, and I've done both of them. It's really easy to do with the scissors. Just pinch the back and snap it up, and you're all set. You got perfectly beveled launch lugs. Do not use an X-Acto knife on this. It doesn't work very well. Again, the scissors is great because it just pinches and snips the end off. So this was a 2-inch launch lug. I cut it into 2 1-inch pieces. They're beveled. Another little tip is, of course, to sand the back of the launch lug opposite the line. That's another reason for having the line on it, is that opposite the line on the back of this here is lightly sanded to help the glue stick to it. So to mount the launch lug, all I do is just put a little line of glue. It looks like it's a mess, but once you squish the launch lug on top of it, smooth it out, everything will be fine. But again, you can see this is like a gel toothpaste. Put the A6000 glue on there, and it just simply stays in place. Now just drop the launch lug on top of it, and you're all set. Okay, so the 2 launch lugs are on. I put one down near the bottom, one near the top. And with this E6000, if you want, you can smooth it up by just putting a little spray of rubbing alcohol on your finger, and then just kind of rub it along a little bit. That'll smooth it out. Also, it will tend to contract a little bit as it dries. So if a little bit of it is squishing out in the sides, as it dries, it's going to like pull in really tight. So there's the rocket. It's basically done. All I'm going to do is let everything dry overnight. And then tomorrow morning, I'll have to start painting it. I'll start out with the coat of a special type of primer. The primer I like using is actually a filler primer. So what ends up happening is it'll soak into the pores. Makes a very, very smooth surface. So let me go ahead, do that tomorrow morning, and then I can start painting this some particular color pattern. But that's it. Looks like it's all done. All I need is a name for this rocket. I don't exactly know what to call it. It's a very bizarre look, but hey, this ought to be a really fun launch. We'll get it going. So here's the rocket. It's all built, and it looks really, really nice. For a custom design, it turned out quite well. Looks good. And the next step is to start painting it. But before I do that, I'm going to discuss some vulnerabilities, namely where I expect this to fail as a rocket. And it's always good to think about that because it may get damaged in certain situations more easily than others. So I'm going to go ahead and discuss 2 potential areas where I think damage may occur as I fly it. So I would like to discuss several vulnerabilities on this rocket, namely areas where I think it's actually weak. It's always a trade-off. You can make it look a certain way, you can make it fly a certain way, and you can also think about how it can fail. These are all things that you might need to think about as you build it. So for this rocket, it's actually a very nice design. It turned out really nice the way I just kind of envisioned it. But one thing that's really a little bit challenging is the fact that these fins are swept back quite a distance and they come to a very sharp point. I look at this being a potential failure mode on the rocket because rockets tend to land tail first, and I expect that these points might snap off. So it looks cool, it looks nice. The balsa wood is relatively thick. I did treat this with a sealer which strengthens it. I'm now going to treat it when I paint it with a particular primer which will make it much more stiff as well. So I do tend to treat the fins multiple times, but still, if it's going to land on the tail, these little pointy sections might break off. It's okay if it does. I'm just going to simply cut it square on all 3, just have square bottom fins. So it's good to say, well, if it breaks, what do you do? And this way I can keep flying this rocket and have a lot of fun, even if it does get that type of a damage. So again, long thin fins, maybe a little bit of a challenge on weakness, but we'll see. We'll see if all the treatment I've done helps it, prevents it from breaking off and strengthens it a bit. The second vulnerability on this rocket is actually something that's somewhat self-inflicted. Namely, I knew that by making a particular design choice, it would make it vulnerable to damage. In this situation, these particular fins, it's always good to have your grain lined up with the leading edge, and I'm going to talk about that a little bit more in a moment. But I also made the design decision to put the fin backwards just a little bit so that the engine is flush with this little point here. So it just kind of looks kind of interesting, looks a little bit better. However, if we look at this, usually the breaks occur when you like fold along the grain. So if we look at this, this part is not glued onto the body tube. So I would expect, let me get a pointer here. I would expect that if this fin were to break, it would break along the grain, down this direction, all the way down to here. And that's going to probably split off this bottom. Now that's a possibility because that's actually the weakest part. The reason is everything else is glued into the fin with two fillets of the Titebond 3, but this doesn't have anything gluing it down. So this part here can flex back and forth. But again, based on the fact that I do use a wood sealer to strengthen it, I'm going to use a filler primer, which is going to strengthen it. So hopefully that won't happen. But again, it's a weakness. It's a possibility what could happen. And there's always this question about wood grain when it comes to somewhat odd-looking fins like this. Notice the wood grain is sticking straight up. And there's always a lot of discussion in terms of which way the wood grain should face for something like a trapezoidal or even an elliptical fin. In this situation, lining it up with the leading edge would not be much of a benefit because it's going to give it a stronger leading edge, but the trailing edge is going to be much weaker. This particular solution, what it does, it makes all of the directions of the grain face the same way, and it's on a symmetrical fin. So what's going to happen is it's going to give an overall general strength all the way across the fin, rather than more strength in the front and less in the back. In general, and this is something I always argue with other Rocketeers, the fact that every point on the outside of the fin should have a path through the grain onto the body. That's what you're really looking for your maximum strength for reliability. If there's a situation where a point on the fin through the grain does not hit the body, that's where it will probably break. Now, I was just discussing, that's exactly the situation over here. This entire fin has a path through the grain down to the body, except right here, about 1/4 of an inch, path through the grain does not hit the body starting right here. So this is where it's very susceptible to breaking. Okay, so there's a lot of interesting things with these materials, and if you use them in certain ways, they are extremely strong, but you have to recall that there are some limitations to what these materials can and cannot do. One step I like to do when prepping for painting is that I like to take a paper towel and I stuff it into the launch lug on both ends. A little piece right here and a little piece right here. And the whole idea, see if I get a little closer on that. Okay, yeah, so you see there's a little wad of paper towel in it right here, and a little wad of paper towel right there. The whole idea is that when I'm spraying this, I'm going to spray this with a primer. I'm going to put a base coat on it. I might put some sparkling glaze on it. All those coats, I don't want stuff running inside of the launch lug. And doing the same thing with the back launch lug back here. And it's good to do this. You put that in there, and it keeps the launch lug clear, keeps it clean, and you don't have to worry about any of the paint or stuff getting in there, making your launch lug sticky. Again, little things like this do help. So go ahead and plug your launch lugs like this and start painting. For a primer, I like to use this. And I usually don't try to endorse one product versus another because that's more of a personal choice. I've used many types of primers, but this one is interesting. It's a filler primer, and it's made for automotive use. It has a couple of special characteristics. Being made for automotive use, you can put the stuff on and it really, really hardens your rocket body. So your rocket body, your fins, everything becomes incredibly tough because this stuff is made for use on cars. So it's really, really nice for really making your body much, much stronger. The second thing, this is a filler primer. So when you spray it on, it'll tend to fill into the gaps, into the grain. And I do not put much preparation on the fins, but yet after this and a coat of paint, they look like they're smooth as glass. So again, you can do a lot of really nice cleanup on your rocket just by using something that's a filler primer as opposed to other types of primers. The other thing is that this dries in about, I guess about 3 to 4 hours. You can wet sand it after 3 to 4 hours. And if you let it dry for an entire day, you can dry sand it. So if you have a bunch of globs or some runs, just wait a day and just sand it right off with some sandpaper and you'll be in good shape. Now this is a gray. It only comes in gray. I use this as a base coat. If I'm going to paint light colors, after that I usually use a white coat over this, a white base prime over this. And dark colors, sometimes actually I use a black paint and then I spray the dark color over it. Again, it all depends on how you want to get the looks of your rocket. And there's a lot that can happen in how you paint and how the colors look and stuff like that. But I'm not an expert in painting. I just like to get the finish done as quickly as I can. But also, I really like this stuff because it adds what I like the most, and that is reliability. The strengthening of this particular primer is well worth using this as a base coat. So I had the first coat of the primer on, and I usually need only one coat of this primer. It really doesn't need a lot. Nose cone, usual stuff, sand it down, and then put the primer on. What's important is the way this looks on the body. Look at the body, you see these fins. If you look at that, they're perfectly smooth. They're like a sheet of paper, very smooth. This is, of course, not glossy. This is a flat, so the paint binds to it quite well. So now I'm going to let this dry for a little bit longer. Usually I put this on and let it dry for at least about 2 hours, and then I can give it a layer of paint, and we'll be all set. So you can see, turned out really nice. I got the gray primer on. The paint, what's interesting is that a gray primer on a paint will make the paint look a deep, rich color. If you want the paint to look brighter and vibrant, you should put a white primer over this gray primer. And I do that. If I'm going to be doing like a yellow or a white, or like a hot red, in that case, I usually put a white primer on over this gray. This particular primer is very important because when it dries, it fills in the pores and it turns out very smooth, and it adds a lot of strength to the overall rocket body. So I let the paint dry for about 2 hours. You see, it looks really nice. This is the nose cone, smooth, shiny, and this is just one coat of paint. I didn't do a lot. Again, I'd use that primer, sealing primer, and just one coat of paint. It looks good. Looks good. And for the body, same thing. This one, you can see the fins. They look nice and smooth, nice and shiny. A little bit of grain you can still see. That's okay. And it turned out really nice as well. And again, this is just one coat of paint. Now I put it on. I let it dry for about 4 or 5 minutes so that it stiffens up a little bit, and then I just spray just a little bit light. If you want to call that 2 coats, it's not. It's just one coat that's fairly heavy. I just do that so that it doesn't run all over. This particular paint, it's not the gloss on it is not quite as even when it dries. A little strange. It's not quite as glossy here as it is down here. Sometimes what I'll do is I'll put on top of this a clear coat lacquer, which is a really shiny type of reflective type of gloss, and it really evens up the overall tone of the rocket itself. I might put some of that on. Sometimes I use what's called iridescent shimmer, which is a sparkly spray. So what I'm going to do is let this dry until tomorrow. I got to get this nice and dry, because then I'm going to mask down and spray the fins. I'll probably paint the fins a red. What's going to be interesting with the black undercoat, the red will have a very deep red look to it, so I'm going to go ahead and do that. But I have to wait until tomorrow. This has to dry very thoroughly for at least a day before you can start masking and taping it. But it looks good, and the rocket is going to be really fun to fly. I had to put some sparkly stuff on the nose cone, and this is the so-called iridescent shimmer spray. It's meant to be used over a black base. When it's over black, you get these really powerful rainbow effects. When you use it over something that's not black, you get all this really kind of sparkly stuff again. It's just kind of fun to experiment with these different finishes. You can see this particular spray over this green leaves these very, very nice little sparkles on it. When you get this outside in a bright sunny day and you're ready to launch, it looks really, really nice. Also note that it evens up the gloss on it. So this has a little bit more of a shiny, wet look to it. And it stays this bright, gloss, wet kind of look when it dries. But you can see it's also got this nice sparkling to it. So I'm going to go outside in a nice, bright, sunny day, and you'll see the nose cone's going to have all these little sparkles on it. It's going to look really nice. So, okay, let me let the body dry, and I'll finish that up. So I'm ready to paint the fins. I'm going to paint the fins with this. It's a cranberry red. Let's see how that looks when it gets on here. Again, the dark underlayment will make the cranberry look a little bit deeper. We'll see how that looks. You can see I taped everything up. I'm going to paint all the fins red. I could paint each set of fins differently. I just don't want to spend the time on that. So everything is taped down. Again, what I do is in the tail end, sometimes people will put the engine in here with a stick and hold it, but I find it a little hard to do that. Also, it puts a lot of stress on the engine mount, moving the rocket around with a stick on the end. What I do is I just take a piece of PVC pipe, I wrap some paper towel around it, and then just slide it in. This way the PVC pipe goes all the way to the end. It's nice and strong, easy to manipulate, easy to turn around, works really nice. Some paper here to protect the paint, and I'm all set to go ahead and start painting. So again, on the end here, you can see I just put a paper towel in here that I just wrapped that with a piece of tape, and I'm all set. So let me go ahead and start painting this, and I will be all set to hopefully give it a second coat later on this afternoon. Temperature outside is about 20 degrees with like 15-mile-per-hour wind, so it is not a good day for painting. Nevertheless, I have to keep on building, so let's see what we can do. Okay, so this is all painted. The red is done, the black and the green. I took all the tape off, so this looks really, really nice now. Notice the green has this really, really super shiny, sparkly stuff that I put on there. That's called iridescent shimmer. The fins actually look really, really nice. If you look at this up close, you see that there's very little wood grain that you can see on this. They're very, very smooth, very reflective almost. The body itself has only one coat of paint, the black. Maybe I should have put two on it, but this particular paint, even though it is a gloss, it's not a very shiny gloss. So it does look just a little bit more dull than the other two. What I'm going to do is to spray the entire rocket with this color shift iridescent shimmer. And usually you put it over a black base, in which case you get this really interesting sparkle effect. So this is going to have a lot of sparkling effect on the body, less sparkling effect on the fins, and you can see on the nose as well as green, so it's got a little bit less sparkle, but there's still quite a bit. Anyways, it's a really interesting thing. I like to experiment with some of these particular various types of paints. This is actually a lacquer, and I put this on to give it that really sparkly look. There's some of these that are really high gloss that look like this, but they don't have the sparkle in it. So anyways, I'm going to do this because the sparkles when it's on the launch pad, believe me, it looks really, really cool. People notice how the rocket looks. It's got these colory rainbows and sparklies. When you put it onto black, not only do you see sparkle, but it also creates various types of color rainbows on it. I'm going to go ahead and do that. Also stuff a paper towel on the tail end and spray the rest of the body. And then I'll be done with the painting and the body preparation. After all of this, then I'm going to start working on the recovery system. So I gave the rest of the rocket body a coat of this iridescent shimmer. See, it's got this really nice sparkly look to it, so the red looks sparkly. If you look at these fins, you can see they almost look like plastic now. They're so smooth, shiny. They look really, really nice. Virtual no wood grain at all. And again, the fins have kind of like a plastic look to them because they're so shiny. The rest of the body, you can see that the black gives a multicolor sparkle on it, whereas the red and the green gives a slightly different effect. This is just what it looks like underneath the light here where I'm recording. I'm going to take this outside. It's a nice, bright, sunny day, and take a look at this in the sunlight. And here's a very, very nice close-up of the paint. It looks like out in the sun. So I hope you have all enjoyed this video. I really enjoyed making it because I put together all of the very fine details that I put into building these low and mid power rockets. As you can see, by using things such as E6000 glue, CA glue, wood glue in various specific cases, you can make a very, very good build. Some of the painting, it's again up to you what you want to do with that. I just try to do it so that it just looks good. But people can do much more detail on that if they want. So that's it for this video. This video is the only video that you really need to understand if you want to build really good low and mid power rockets. What's also important is that the rocket has the swivel on the end right here, which allows you to connect almost any type of recovery system to it. And I'll be covering that in a separate video. So again, what's nice is you can build the rocket completely separate from the recovery system and hook them together any way that you want. What's interesting about this particular rocket, you can see the 71 on here. This is my rocket number 71 that I built. So there's a bunch of other rockets laying around, some of them still flying, some of them not. But 71 is my build number for this particular rocket. I still don't have a name for it. If you have an interesting name for it, let me know. Thanks.